Hello students, today our topic is about trusses. So we are going to discuss about trusses. Trusses. This figure is called as a trusses. Trusses is a rigid structure composed of number of straight members pin jointed to each other. So basically trusses are the straight members which is connected at the joints. Trusses are the straight members which is connected at the joint and which is designed to carry the loads. Basically trusses are designed to carry the loads. Trusses used in bridges, buildings, transmission towers to support inclined roofs in railways platform and also godowns. Now we will see the classification of trusses. A truss can be classified in following categories. Trusses classify in two types. First is a perfect truss, which is also called as a stable truss, and second is an imperfect truss, which is called as a unstable truss. Now we will see the first type, that is called as a perfect truss, means stable truss. A truss which does not collapse under the loading is called as a stable truss. A truss which does not collapse under the loading is called as a stable truss. Also, a truss in which the condition n is equal to 2j minus r is satisfied is called as a perfect truss. If this condition is satisfied for a given trusses, then we call that given truss is perfect. Means n where n is equal to number of members, n is equal to number of members, where j is equal to number of joints, r is equal to number of reaction components. Okay, n is equal to 2j minus r. When this condition is satisfied, then given truss is perfect. Okay, let us see one example. This is a triangular truss. This is a figure of triangular truss where at the point A is hinge support and at the point B is roller support. Okay, first we have to draw free body diagram of this figure. Whenever hinge support is there, there are two reactions. One is horizontal and one is vertical. And whenever roller support is there, there are one vertical reaction. So free body diagram of this figure is here. Whenever hinge support is there, there is two reactions. One is horizontal AX and one is vertical AY. And whenever roller support is there, there is only one vertical reaction. Okay, so here we have to use this condition, n is equal to 2j minus r. N means number of members. So how many members are here in this figure? Member AC, okay, member AC, then member CB and member AB. So how many members are here? Total number of members is equal to 3. So n is equal to 3. Okay, J means what? Number of joints. How many joints are here? Joint A, see here, joint A, then joint B and joint C. So joint A, joint B and joint C. How many joints are here? Joints 3. So J is equal to 3. R means what? Number of reaction. Okay, so how many reactions are here? AX, AY and BY. So here total number of reaction is equal to 3. So n is equal to 2j minus r. N is equal to number of 3 numbers of members is equal to 2. J means number of joints, that is n is equal to 3 and j is equal to 3. Number of joints is equal to 3. Total number of joints is 3. And R means number of reactions. So how many reactions are here? Total number of reactions are here 3. AX, AY and BY. Reaction is 3. So 3 is equal to 6 minus 3. So 3 is equal to 3. So left is equal to right side. So this is example of perfect truss. Whenever this condition is satisfied, we can say that given truss is perfect truss. Okay. Now we will see imperfect truss. We will see imperfect truss. This is a second type, imperfect truss. A truss which collapse, a truss which collapse when loaded is called as a unstable truss. Okay, a truss which collapse when loaded is called as a unstable truss. When n is equal to 2j minus r, this condition is not satisfied, then given truss is called as a imperfect truss or unstable truss. Okay, now we will see the methods of analysis of trusses. The analysis of perfect trusses is carried out by different methods. There are two methods of analysis of truss. First is method of joints and second is method of section. So here we shall discuss first analytical method, that is method of joints. Method of joints. This method is useful in finding forces in all members or number of members of a trusses. Basically, method of joints, this method is used to find the forces, means magnitude of forces in all the members of the trusses. Okay, so we will see basic steps in analysis of trusses by method of joints. So first step is you have to draw free body diagram, then check the stability of trusses by using this condition, means n is equal to 2j minus r, where n is equal to number of members, j is equal to number of joints and r is equal to number of reaction. Okay, I repeat, first you have to draw free body diagram, then check the stability of a given truss, whether truss is perfect or not. Then second steps, consider free body diagram of entire truss. Consider free body diagram of entire truss and calculate the reaction components using three conditions of equilibrium, that is summation of fx is equal to 0, summation of fy is equal to 0, then summation of m is equal to 0. Means you have to find reactions by using these equilibrium condition. That is step number 2. Then step number 3 is select a joint such that there exist maximum two unknown forces. Okay, select a joint such that there exist maximum two unknown forces. Now we will see the step number 4. Step number 4 is draw free body diagram of selected joints. Draw free body diagram of selected joint by assuming forces in members as away from the joint, that is assume tensile forces. Okay, means you have to select each joint individually and then direction of that forces, means direction of that members of a forces is away from the joint, is away from the point. Okay, then step number 5, the forces of a joint are concurrent and each joint is in equilibrium. The forces at a joints are concurrent. Concurrent means which is passing through the same common point. Okay, and each joint is in equilibrium. So apply two conditions of equilibrium, that is summation of fx is equal to 0 and summation of fy is equal to 0. Okay, means here we have to use these two equilibrium conditions by finding the magnitude of forces in all the member of trusses. Then step number 6, repeat the procedure by selecting different joints and find out forces in all members of a trusses. Repeat the procedure by selecting different joints and find out forces in all member of a trusses. And last step, step number 7, tabulate the result in a force table using positive as a tensile and negative as a compressive. In last step you have to prepare force table. Okay, you have to make a 4 column. First is serial number, means how many members are here, you have to put the numbers. Then members, how many members are here, means members name, that is member AB, member CD, member BC, like that. Then magnitude means you have to put the values of that forces, that is if it is positive 50 kilonewton, then your nature is tensile. If it is positive, you have to put In nature column, it is tensile. If it is negative, you have to